I'm going to show you how to do chi-squared tests of independence in SPSS. First of all, remember, a chi-squared test only compares two categorical variables or two nominal variables. So what we have here are all categorical variables, all nominal, right? I color. So here's what the numbers stand for in the data set. 1 is brown, 2 is blue, 3 is green, 4 is other, like red or black or evil. And then whether somebody is over 35 or not, 0 is no, 1 is yes. What their professions were. So we have teachers, psychos, business employees, professional athletes, carpenters. And of course, gender. 0 is male, 1 is female. So that makes them all categorical variables. So first of all, I'm going to see if there's a significant association between eye color and anybody under or over 35. I'm going to go to Analyze. Descriptives, crosstabs. Crosstabs is chi-squareds. There's another chi-squared function on here. Don't use it. Crosstabs. What did I say? Eye color, over 35 years old. So you go to Statistics. You want the chi-squared test statistic. You want the phi and the Kramer's V. Continue. Cells. You want the expected count if the null were true, and the standardized residuals. So if there was a difference, the standardized residual will tell you where it is. Continue. Let me show you how to read the output. First one tells you how many you have, 179, which is pretty darn good. Don't worry about the missing. It's a data screw up on my part. So here is the cell count, right? So the expected count, if the null were true, would be along this row. And this is the real count, also called the observed or the actual count, whatever you want. So if the null were true, they were expecting 30.4 people with brown eyes to be under 35, and they got 30. Okay? Those numbers are practically the same. Everything's practically the same. So don't be disappointed if you don't get a significance here. But to check the significance, you simply go to the chi-square text box. See that? It says Pearson's chi-square. Same guy that did the correlation. So the significance value, is 0.823, which is not under 0.05. Therefore, you cannot reject the null. This was muy importante. Make sure you understand this, right? If the sig value, the p-value is less than 0.05, reject that null. If the sig value is greater than 0.05, do not reject the null. And what does the null say? It says that there are no significant associations between the variables. All nulls are the same. Please remember this. This is how all of these statistical tests work. All right, back to the show. So in plain English, that means that there is no association between a person's eye color and whether they're over 35 years old or not. Okay, let's keep going until we find one that has significance. I'm going to compare crosstabs. Let's check eye color with profession. Okay, everything else should be preset. Click OK. So I'm going to go right down to the chi-squared box first. And sure enough, there is a significance. Okay, so it means there's a weird association between a person's eye color and their profession. So let's see where that is. Right off the bat, I see a standard residual of 1.8. They expect about 21 brown-eyed teachers, and they got about 29. That's a 50% increase. That's kind of significant, I guess. Let's see what else we can find. Look at their standard residuals. Anything above 1.6 or something. There's one. Boom. So business employees with green eyes, they're expecting about 15. They got 21. That's higher than expected. Anybody else? Here's one. Other teachers. Teachers with other eyed colors. They're expecting about 2, and they got 0. Not that big. But that's where the significant association is. Okay, the main one is they have a lot more brown-eyed teachers than expected. So that's how you do it. So since there is a significance here, last thing I'm going to show you is you're going to look up what we call the Kramer's V. Hold on. It's way down here. If it is significant, you look at the Kramer's V, and that is roughly your effect size. So in other words, about 22% of the variance of the relationship of the association, 22% of it you can explain by what your variables were. So eye color and profession, we can explain about 22% of the variance there. So that's how that works. MGZ out.